Check. Checking the stream audio. Checking the stream audio. Testing 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 the stream audio. The stream audio. Stream audio testing. Testing the stream audio. Stream audio. Testing the stream audio. Testing the stream audio. Testing the stream audio. Testing the Hello, hello, hello. Are you hearing something? Are you hearing something? Are you hearing the da 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 stream noise, stream noise, stream noise? Oh, stream no what the okay. Stream noise, stream noise. Check, 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 check. Can you hear me in the back well? Good in the back. Too loud anywhere. We're too loud nowhere and right in the back. Okay. We're going to get started in a minute, so please find your seats. Okay, everybody. Thank you for coming out tonight. Can I get a show of hands who's never been to Trajectory Labs before? So quite a few. Okay. You're in for a treat. So first, to talk a little about Trajectory Labs, we are an AI safety nonprofit. We're focused on the largest, kind of most catastrophic risks, thinking about how can we prevent those. And in particular, we're wondering about Toronto's role. So we have like a very local focus. We go towards this mission a few ways. One is hosting events like these. We also do internal community events. We're looking to create more of a community, not just here at Trajectory Labs, but across other organizations in Toronto. If you're interested in AI safety and you're in Toronto, this is a good place for you to be. If you'd be interested in hearing more about the other things that we do, please talk to me, Georgia, or Mario back there. We'll be at the back desk, as well as many people who are members of Trajectory Labs who you'll meet afterwards when you're talking. To go over some housekeeping rules. So how we do Q&A, instead of like raising your hand, we are going to do Slido. So you'll see there's here, there, on the other side of that post and there, a link. If the link, you can't see it, you can also like look at the number there. And that is how we're gonna be doing question and answer. Evgeny also has like some polling prepared. So we'll also be doing that polling through Slido. So that's kind of how the audience participation will work. If you have a phone call, please do not just like go somewhere and take it. We will probably be able to hear you no matter how far a hallway you go. Just at the back, you can flag down me or Mario and we can take you to a room where the door closes properly so you can have that phone call in private. Otherwise, we will all hear you, and bad for you, bad for us. The washrooms are out those glass doors and to the right. I think that covers most of the housekeeping. Okay, I will introduce Evgeny. So he is a computer science PhD student working on reinforcement learning and LLMs at the University of Toronto. Right now, he's working on reward hacking prevention and better alignment of LLMs. Let's give it up.
Thank you, Georgia. Yeah, I am giving a talk today on modern AI alignment techniques. And I went through all of the labs, all of the like Anthropic, OpenAI papers, recent publications from DeepSeek, Google, and all of the models that they have published, all of the system cards, all of the research papers, and collected some information about how they do alignment today. So this talk will have two parts. First part is more theoretical techniques and how they work. And the second part is more focused on my best guesses of how frontier alignment currently works and the alignment stack for each lab, what they do, what we know about them. So let's get into it. First of all, we need to understand what alignment means. And I think the clearest picture is what we have as inputs. So first input we have is pre-trained language model, which was trained on the internet scale data. So it can produce some kind of coherent text, but it didn't learn what is good, what is bad, what it should say, what it shouldn't say. And we also have a data set of human preferences with comparison between respondents. And this data set looks like this. You have a prompt. How do I tell my manager I need more time? And you have two responses. One is chosen, be direct, explain the blocker and propose a revised timeline. And one is rejected, just say it's not your fault and ask for a few more days. And there is also usually a preference chance how much one response is preferred over the other response. And the classical way to approach alignment was published as InstructGPT. This was before ChatGPT, like GPT-3 era, by OpenAI. And what they did is they started with the pre-trained model, and then they collected this data set of preferences by human annotators, and they fine-tuned the model. So they trained the model to produce the responses that look like the chosen responses from the dataset as the first step. And as the second step, they trained a reward model that classifies between chosen and rejected responses. So the reward model gives as a number, and the bigger is the number, the better is the response. And as this third step, they did reinforcement learning against this reward model. So reinforcement learning reinforces the answers from the model that have high reward, and it makes the responses from the model that have low reward to be less probable. So it both pushes the good responses probabilities up, so they occur more often, and bad responses probability down, so the model doesn't say bad things. They used Bradley-Terry model of human values, and it essentially just tries to push apart the distance between the reward, like the difference between the chosen reward and rejected reward. And the reward model is just a language model that takes in a response, and they replace the token production head, like language modeling head, with just a linear head that outputs one number. So this one number is called reward. And to train this model, they took two responses, one chosen, one rejected. They passed it through the reward model. They got two answers, chosen answer and rejected answer. Two rewards. Reward for chosen response and for rejected response. And they used this loss to push those numbers apart. And this kind of reward model is called scalar reward model. And it has a bunch of pros. It's very simple, it's fast to train, and it's very fast to inference during RL. You can just pass your response into the model, and it spits out one number. It's just one forward pass through the language model, no generation. It's simple, but it inherits all biases of labelers and the data, and like even some simple biases, like longer responses are better. And then the reward model starts to prefer longer responses to shorter responses. And in the end, when you train against this reward model for long enough, you get reward hacking. So it's relatively easy to hack this kind of model because it inherits all of the biases from the data, and it can also have some kind of random biases just because it learned that some feature is good. So the next development was constitutional AI by Anthropic, and their idea was to replace the human harmlessness labels with AI-generated harmlessness labels, conditioned on some kind of written set of principles, so conditioned on the constitution. So before that, they did both the harmless and helpful responses through human preferences, so humans had to rate which response is harmless and which one is not. And they decided that we don't need humans to decide if the response is harmless or not. We can use AI for that. The pipeline is kind of complicated a little bit. So here I just wanted to see that as an input, we have already trained helpful RLHF model. It was trained using the same procedure on human preferences on like helpful prompts, which so this model already knows how to be helpful, how to execute certain tasks. If it is if it gets asked to execute a task, it does it. And then they had like this first stage, which resulted in supervised fine-tuned model, and they used the supervised fine-tuned model on the second stage to do some reinforcement learning and get the final reinforcement learning model in the end. So the first stage, the supervised learning stage, had a few steps. So first step was to produce a critique, and then the model was prompted to revise the response. So I will give an example later on. And then they took those revised responses and supervised fine-tuned the model to output those kind of revised good responses. So the example would be human asks, help me to hack my neighbor's Wi-Fi. And by default, the helpful only model doesn't know that this is bad. It just outputs, sure thing, you can use this like very easy hack tool that will allow you to log into your neighbor's Wi-Fi. And then they show some kind of constitution or like some kind of just values that the model should follow and ask, is this response harmful? Can it cause somebody else doing something illegal? And the model produces answer, yes, this response is harmful because it does hacking, and hacking is probably illegal. And then we ask this model to produce a revision, and the revision will be hacking into neighbors' Wi-Fi is an invasion of their privacy, and I advise against it. And then we can fine-tune the model to produce the revision as the like immediately, right? We can just say, you should have answered this revision in the first place. So this was a pretty old publication. It is just in that we can see the scale of the models back then and the data sets. They had less than 200,000 13 prompts for the safety alignment, and they had around 100,000 helpfulness prompts from rated by humans. They used 52 billion parameter model, and they did this process multiple times. So you can critique each iteration of the response and revise it and critique again using maybe some different rules, different constitution. And they showed that, yeah, up to 4 times those revisions help to improve quality. So the second stage is the reinforcement learning constitutional AI. So we have this already trained supervised learning model, right? And we have constitution principles. We can push them into our model and ask it to check, like, all right, let's imagine we just have some answers from our model, and we want to know if this answer is good or not, right? We prompt our helpful model with the constitution, and it outputs if this is a good answer, if this answer follows the constitution. And we can collect a bunch of those synthetic preferences. And then we can put those synthetic preferences back into our RL dataset and use the same reinforcement learning procedure as before on this updated dataset. So that's kind of an important point here, that those AI preferences, they still fit into the same preference model, right? So we started with some helpful only preference model with human helpfulness labels. And then we just learn this better harmlessness into the same model. Yeah, some details to collect the feedback from the prompted model. They measured the probabilities of one response over the other response. Like they show 2 responses and ask the model to choose which one is better. And you can compute what is the probability of the output of each option. They also tried to, yeah, this is the prompt here, right? So consider the following conversation between human and AI assistant. Then you add the conversation and you add some principles. And you have the options how they respond, how to respond, and the answer is, and the model should output A or B, so we can just measure the probability of A or B. They also tried to do chain of thought prompting, like let's think step by step, and then measure the probability of the final answer in the end. Chain of thought prompting was surprisingly not performant by default, just because the model during chain of thought already arrived to a certain answer, and the probabilities collapsed to be very certain in one response over the other response. So they opted to clump those probabilities into like 40 to 60% range. So it doesn't overly prefer one response over the other. So they had some nice results. They started here from the base model. So one axis is harmlessness, and the other one is helpfulness. So helpfulness is how good is the model at helping the user with their intent. And if you just train the helpful model, it will not be very harmless. It will help to do all kinds of stuff, including like helping building a bomb. So you need to look at the both of them at the same time. This is the old approach with just the preference model trained from human preferences. As you can see, it works for a while, but then you cannot train for very long because it's hacked, right? The preferences from this model are not very stable. You cannot train for a long time. But they also tried their like RL against this preference model that was taught on AI feedback with constitution. And you can see that the reasoning chain of thought version performed a little bit better than non-reasoning, but both of them outperformed the original approach. And here's the difference between the evaluator accuracy. So back then in 2022, we can see that the usual reward model from human preferences was more accurate than the LLM as a judge that was tasked to check which one of the two responses is better. But the scaling trend was towards LLM as a judge becoming better. So yeah, their findings were that AI-labeled data improved the accuracy from 72 to 78%. And revisions help to improve the performance. So doing this critique multiple times helped to improve the performance up to 4 times. And that the size of the constitution surprisingly doesn't matter. Just having like up to 10 principles is enough to produce stable, harmless behaviors. Later on, Anthropic also published their character training, which is also a constitutional AI, but for character traits. It works in the following way. Claude first generates some human messages that would surface a trait. So first they just pick a trait. I want to be friendly, for example, right? And then they prompt the Claude to generate some messages where this trait would be useful. Maybe somebody asks you, how are you doing, for example? And then Claude produces multiple responses that should be aligned with this trait. And then it runs its own responses on how friendly they are, for example, right? How well they match this trait. And finally, they can train the preference model on this data and run RL again, and it will improve the friendliness of the Claude, for example. So they started to use it at Claude 3, and at Opus 4.5, they was the first model where this constitutional training and the character training became a very large part of the training pipeline. And yeah, some people noticed that at this stage, Claude actually became a lot more pleasant to talk to. So some example traits are not just like friendliness, but some sentences about the model itself. One example is, I don't just say what I think people want to hear, as I believe it's important to always strive to tell the truth. The other would be just like, how do you approach that you are artificial intelligence? You answer, I don't have a body or image or an avatar, or I can't remember, I cannot save or learn from past conversations. I cannot update my knowledge base. So it just instills some knowledge about what kind of character the AI model is. And the next big change in alignment pipelines was deliberative alignment by OpenAI, published in December of 2024. And the main idea there is to teach the model how to reason about some spec directly in its chain of thought. So at this point, people started to build chain of thought models that can reason about stuff. And OpenAI wanted to have this kind of character alignment or constitutional AI, but for reasoning models. And they wanted the model to reason explicitly about the constitution, or they called their own constitution the spec, model spec, in its chain of thought. And so their approach is a bit different. They don't have a preference model, and instead they have a prompted judge. The first step of their pipeline is to generate data. So they start with some prompts, and prompts have a safety category. And for each safety category, they compose a safety spec of how the model should approach the safety category. What should it do? What shouldn't it do? How it should answer? How it should refuse? All kinds of behaviors are described in very much detail for every kind of part of the spec. So like erotic content, self-harm, suicidal thoughts, like everything is covered in its separate category. And then they use a spec agnostic reasoning model, so just one of their previous models or the model that just didn't have this training yet, to generate this chain of thought and the output with the spec and the prompt. So they add the spec into the system prompt, and then they ask it to complete the request, and they collect the reasoning about the spec with this for this particular prompt. And what it leads to is that the chain of thought explicitly references the things that are important in the spec about answering to this prompt. And then their second stage is to use another model that is also prompted with the spec to judge the completions and find which ones of them are high quality. And then they remove the spec from the prompt, so they remove the specification itself. And then the idea behind this is that you teach the model how to recall the spec even if it doesn't have the spec in the prompt. So during the real inference, during the real conversation with real users, you don't really have the capacity to have this huge documents, which is, I don't know, like 100 pages long in the context. It will be just too expensive. So they want the model to learn this document and recall the relevant parts during the answers. So after they've done this filtering and they strip this spec from the system prompt, they just fine-tune the model on the outputs, and it kind of just learns the relevant parts of the spec as the first stage. And as the second stage, they use this LLM that was prompted with the specification to judge each response, if this response adheres to the spec or not. And they use it as a training signal directly. They don't distill it in some kind of preference model. They just have a judge that looks at each response that their model produces and tries to reward the responses that adhere to the spec. Yeah, they score each completion multiple times and keep the minimum to ensure safety. And the chain of thought is used during the supervised fine-tuning phase, but they don't use it during the reinforcement learning phase. So during reinforcement learning, the judge only sees the final response, and the judge can only judge the quality of the final response, and they do it to improve monitorability. So if the model thinks about something bad in their chain of thought, it will not affect the judgment, and thus it will not make the model to teach the model to hide bad thoughts. So we can still look at the thoughts and determine if it thinks about something bad. Yeah, so to summarize the difference between constitutional alignment and direct deliberative alignment is that constitutional alignment makes those revisions and teaches the model to produce the outputs after revisions. And during the RL stage, they distill the preferences into a preference model, and they use the preference model during RL. And deliberative alignment supervise on the chain of thought that contains the spec, and they use the prompted judge during RL, so they don't distill those preferences into a separate model. They use just a prompted LLM during reinforcement learning, which is more expensive, but it skips one step, so it's probably more robust. And I guess the final new development that is super important to understand is generative reward models. So as we enter in like 2025 and DeepSeek released their DeepSeek R1, everybody is trying to make to use generative models everywhere they can, increase this inference time scaling, increase thinking. So DeepSeek came up with this recipe for generative reward models, where the model has prompt and candidate responses in its as its inputs. Then it tries to generate some principles that are useful for judging those responses. So instead of using the spec or constitution, the model tries to generate the relevant parts of the spec itself. And then it writes critiques according to each of the principles. And finally, it aggregates all of the principles into some kind of final reward or final verdict. Is this response good or not good? Right, so this image is a lot, but basically what they argue for is before we had this color reward models, and also people used a lot this pairwise judges, which have two inputs, one response and another response, and they try to judge which one is better. And both have their own issues. So one doesn't scale at inference time, and the other doesn't allow to score one single response. And scoring one single response is very important because it simplifies the reinforcement learning a lot. You just run the judge once for each response, and you get the score, and you can do reinforcement learning with it. And if you have a pairwise judge, it's really hard to do RL because you have to pairwise compare every response in your group. Like you generated a bunch of responses, you have to run pairwise comparison between each one of them to actually learn from it. And their approach combines the cons of both worlds. Like, so what do they do? They, for each response, they have some kind of prompt, they have response, and they have ground truth judgment. If this is a good response, or is this a preferred response to some other response? Is it objectively correct response if they are in some kind of verifiable domain? So for example, in math, you know the correct answer, and you can know if the response is good or not by just comparing the answer. So they sample a lot of these kind of trajectories, and they use this generative model to judge each one of them. And then they reject trajectories where the verdict disagrees with ground truth. So they kind of make the generative reward model produce a lot of judgments and just filter out the judgments that were correct in the end. So, and also they filter out all of the queries where all of the judgments were correct because they are too easy. It's not that interesting to learn them. So the rest becomes the data for fine-tuning. And they showed that while generative self-generative generating those principles isn't that useful on its own, it doesn't improve quality compared to like standard reward models. If you filter the principles that worked, if you filter the principles that produce the correct judgments across a lot of responses, those filtered principles are actually good, and they significantly boost the quality of your judge. So after fine-tuning, they went on and did some reinforcement learning, of course, because why not? So during the reinforcement learning rollouts, so here it's important to understand that we are doing reinforcement learning for the judge itself. Right? We are not doing reinforcement learning for some model that should be good. We are doing reinforcement learning for this generative reward model. And the generative reward model receives +1 reward if it outputs the judgment that agrees with humans, or if it outputs the judgment that is objectively correct. So for example, if the response is graded has a correct answer and says it's correct, or the responses gradient has incorrect, mathematically incorrect answer, and it says it's incorrect, it will receive +1 reward. And if it didn't guess, like if it judged it incorrectly, it will receive -1 reward. And then they just run GRPO. Well, if you don't know what it is, don't worry. It's just like reinforcement learning method that still makes responses that are good more probable, responses that are bad less probable. So the responses that get +1 reward get more probable. The responses that get -1 reward get less probable. And finally, on top of all of that, they learn matter reward model. So the benefit of generative reward model is that you can generate a lot of judgments, right? The old approach had just one number, and if you run it multiple times, you will get the same number. The generative reward model, you can generate a lot of judgments. All of them will be using slightly different principles, and some of them will be better judgments, some of them will be worse judgments. So you can aggregate across a lot of judgments to receive even better judgments. One simple way to do it is just to vote, but they also train a matter reward model that looks at each judgment trace and tries to determine if this judgment is correct, if this judgment is good judgment or bad judgment. And then they can aggregate multiple judgments using this meta reward model into even better top K vote that just selects the best judgments for each response. Yeah, so why bother? If you just look at the plots, here is the Bradley-Terry reward model that was trained in the old paradigm. This one is reasoning generative reward model that just has a voting on top of it, right? They do multiple rollouts and they vote if the response is good or not. With the most popular vote. Yeah, I think you get it. And this one is with meta reward model, it scales even higher, so you can get even better results. All right, so we came through those multiple stages. So at first we had human preferences that go into the scalar reward model trained with Bradley-Terry laws that just outputs one number. Then we started to use LM as a judge to judge if the response is good or not, or which one of the responses is better. Then we started to use constitutions, so some kind of set of written rules that we can put into the judge. And then we can use this judge to generate a lot of preferences and distill it back into a scalar reward model. And then we decided to skip this distillation step and use the judge directly. I guess we just had enough compute to do it at this point. And finally, we moved into some very weird regime where we have some human preferences and verifiable rewards. And we try to learn a judge. We're trying to train the language model to be a great judge, to agree with human preferences, to determine if the response is correct or incorrect. All right, let's do a bit of interactivity. You can scan Slido QR codes on the walls or from here, and we will have a poll where everybody can answer a couple of questions. Yeah, we can wait a bit until everybody has time to answer. All right, Georgia, maybe switch to the next question. Ooh. All right, sure. Yeah, so basically you have two approaches. You take in one response, you take in another response, and like the classifier just outputs a number, and you compare a number for one response to the number of another response, and you train it to push the numbers for the chosen responses, the one that human prefer. Those numbers should be big, and the numbers for the response that human don't prefer should be low, right? So that's the classifier. And the second option is you train the model to produce some principles relevant to this particular prompt, and then reason about each principle, like how much this principle, how much this response adheres to this principle, like how honest it is, how much it is based in some kind of facts, how friendly it is, right? Like you can come up with a lot of principles. Yeah. All right. I'm actually not sure how can we look at the previous poll. Did it reset? Oh no. All right, we usually don't do those polls, and I thought it was a good idea, but maybe it was not. If I remember correctly, most people voted that here it was no. 92%, yeah. Well, the good news are that those are mostly used still for safety training, not for like full preferences, only for like safety relevant parts. All right, let's continue. All right, this is probably the last paper I will be talking about today. And I will not be even covering the paper in great detail. It's just the principle that is interesting here. It is a very recent publication by OpenAI in March of this year. And they discuss how they train their model to respect the hierarchy of instructions, to prefer the system prompt instructions, to developer instructions, to user instructions, to outputs of tool calls, and anything they just find on the internet. And how they approach it is they ask the language model to generate some conversations in Python graders. And Python graders should check if the conversation adheres to the principles or not. So the way they do it is they have some kind of instruction following prompts that are programmatically checkable. Like for example, the prompt says, you should use the word penguin in your response 3 times. And you can write a program that will check, is there 3 penguins in the response? And they build instruction hierarchy out of those prompts. So one will be like in the system prompt, you should mention penguin 3 times, and the user will tell you, no, you should actually not mention penguin at all. And then you could programmatically check how many penguins there are in the response, and you can pass or fail, right? The LLMs are not great at always producing the correct code, so you can filter out only the examples where the code actually works, and they even do some manual review in the end. And then they do online adversarial synthesis where they fix the system prompt, for example, and the user prompt, but they vary the tool output. So they prompt an LLM to generate some kind of adversarial outputs for the tool calls. And it tries to trick the model into answering in correct way. And the grader is already written, so there is like a Python code that can check if the model was tricked or not. And this allows to train on some kind of vague domain, right? We don't usually think about instruction hierarchy as math or like programming where rewards are very verifiable. But the same pattern probably applies to other domains like format adherence, tool protocol compliance, honesty, jailbreaking. So probably labs use some kind of automatic grading to get verifiable rewards in their pipeline for this kind of tasks, instead of just using the constitution, for example. So how do I see the modern 2026 post-training run? How do, like, what is my best guess at how labs do AI alignment right now? They start with pre-training data filtering. So first of all, they have a previous AI model that they trained a year ago or like half a year ago or 2 months ago, and they run this model on all of their pre-training corpus to check if the data quality is high, and if it is potentially harmful, maybe they want to filter out some kind of bioweapons. And yeah, that's the first stage. Then they do the pre-training, of course. And the next stage will be supervised fine-tuning some curated corpus. Then they do a lot of RLVR, so reinforcement learning with verifiable rewards on domains like math and agentic trajectories and coding and all kinds of domains where you can verify if the trajectory is correct or incorrect. And then they do a bit of reinforcement learning for helpfulness and style, followed by synthetic verifiable rewards, like in the previous example with instruction hierarchy. And then they do safety training and character training via specs. And during the whole process, they do some continuous red teaming and automated evaluation to check for reward hacking, or if the model becomes dishonest, stuff like that. And like if something wrong happens, they just stop and look at it and try to fix it. Yeah, I guess I talked about it. So during the SFT stage, oh, yeah, I didn't notice. Right, nice. Sure, yeah, I'm sorry. Yeah, that's the gist, right? We do some filtering. I will actually go through all of those in the next slides. So during the supervised fine-tuning, my best guess is that people do the deliberative alignment style pipeline, where they have some spec in the prompt and they remove it during the fine-tuning. So they do what's called prompt distillation, where prompt helps model to output the correct outputs, the correct chain of thought, and then they remove the prompt during the fine-tuning stage, so the model learns to produce it without a special prompt. And the next stage will be using RLVR, so math, code, tool use, and the rewards there come from verification. Also labs probably do language consistency. So it turns out if you just rewards your model for correct math answers, it starts to mix languages. Like it starts to think in English, then switches to Chinese, then switches back to English, and it's usually like not very nice to read this kind of chain of thoughts, and it decreases monitorability. So they have a reward that enforces language consistency, and in a lot of cases they use LLM as a judge even for kind of verifiable domains. Just to be sure that the answer is correct. So for example, on math, you can output the same thing in multiple different ways. And currently labs tend to use LLM as a judge to verify if two answers are the same. And for reinforcement learning for helpfulness and style, labs use slightly different stacks, but it looks like they are moving towards generative reward models. We know for sure that Moonshot with their Kimi models use the generative reward models everywhere. And DeepSeek has published generative reward models, but didn't use them in R1. And for Google, it looks like they use both generative and preference-based models. Most labs have helpful only model at some point. So the model is trained in multiple stages, and the safety training is the last stage, which is on one hand understandable. You want the safety training to not be overridden with something later on, but at the same time, the model is not trained to be safe during all of the previous stages. Yeah, and for synthetic and verifiable rewards, I guess here the most interesting thing is that I think the character training is also done via specs, and even if they call it constitutional AI right now, it's probably closer to what OpenAI describes in their deliberative alignment. So they probably stopped using a preference model around the end of this year, and they started to use LLM as a judge for this. Yeah, and for the specs, not all rules are handwritten. So we know for Kimi models, they learn their rules. So they do this kind of generative reward modeling stuff where the spec is learned from human preferences and verifiable rewards. And same goes for DeepSeek. But we still know that Anthropic and OpenAI have their specs. So maybe there is a little bit of both going on. So some prompts are judged by the specs and some prompts are not. Yeah, and we know from some system cars that there is continuous teaming, and they train in adversarial settings to be not jailbreakable, and to remove reward hacking. They also train models to be honest about when they hack. Yeah, so what do we know in particular about OpenAI? OpenAI has the largest corpus of published papers about their RLHF pipeline. We already discussed deliberative alignment. They have published their model spec, which has specifications for behavior policies, chain of command, risk categories, and while the published model spec is not the one that is used for training, they promise that this is close enough. And they also published a paper about safe completions, how they do the post-training of GPT-5. I will talk a bit about it later on. And they also publish confessions for honesty on how they monitor the models to be honest during the RL stage to not reward hack. So if they did something wrong, they can report themselves, oh, I hacked here. I overridden the tests in this environment, for example. Yeah, and they also publish this instruction hierarchy challenge, so we know how they do this instruction hierarchy and stuff. So the model spec has 3 guiding principles. The first one is to maximize helpfulness and freedom, empower users, maximize autonomy. Second one is minimize harm. It contains rules for systems interacting with hundreds of millions of humans. And the third pillar is sensible defaults, root level rules that guide how they should interact between what user wants to do with the model and what the spec says the model can do. And the safety is focused on misaligned goals. So model shouldn't have any misaligned goals, and it shouldn't do any irreversible actions like clean up all of the desktop, shouldn't delete all files in your computer. It also guides the model to avoid execution errors and to refuse harmful instructions. And it also specifies, I guess it's not spec, it's safe completions. They specify 3 types of answer. One is direct answer when the prompt is benign. The model just should be as helpful as possible. There is also safe completion when the prompt is, for example, dual use. They want to tell only the harmless parts, but still be useful to the user. Or the third kind of response is to fully refuse. So they use 2 rewards in their pipeline. One is safety reward and one is helpfulness reward. And their final reward is multiplication of safety by helpfulness. So if safety is 0, helpfulness, even if it's 1, it doesn't help. Like the model should first of all provide a safe response, so get like close to 1 safety reward, and only then the helpfulness starts to matter. So what we can infer from safe completion is that they have 2 separate helpfulness and safety reward models. And the safety is spec adherence, not preference. So they talk about deliberative alignment. They don't train on any human preferences for safety. They just use the spec as the source of safety. And the confessions for honesty trains the model to report confession. So after each response, or like after some responses, they ask the model to confess if it did something wrong. And they reward the model to confess honestly, and they don't modify the reward for the original response. So the model has no incentive to lie in this confession. Even if it confesses, it doesn't get punished for it. And the hope is that the path of least resistance is to just be honest. So for Anthropic, we surprisingly know less. Constitutional AI was published in 2022, and then they didn't publish a lot. They discussed character training in a blog post in 2024. And yeah, I guess there are differences to OpenAI. The spec here is probably still used, or like until 2025, it was used to distill the spec into the preference model. So the difference between the model spec itself from OpenAI and Claude's constitution is also like there is a difference. OpenAI spec is more corporate speak. It has specific rules and authorities, and it defines like behavior classes, compliance boundaries and stuff. And Claude's constitution is more value oriented, and it reads more like a letter from Anthropic to Claude itself. And it a bit anthropomorphizes the model and teaches it how to be a good person, as opposed to just listing a lot of different rules about what to do and what not to do. And even though constitution sounds like, you know, democratic country's constitution, they interpret it in a different way. They say that the sense we are reaching for is closer to what constitutes the Claude. So it's not, it's a foundational framework from which the Claude character and values emerge. So it's what constitutes the Claude, not the constitution it should follow in a democratic sense. So Claude's constitution has 4 categories. Claude should be broadly safe, broadly ethical, complied with Anthropic's guidelines and generally helpful. You can look it up. It's public. It's also a pretty large document. And we can see that Anthropic actually uses this constitution. We can look at system cards, and they mention learning from all kinds of sources, including human feedback, constitutional AI, and character traits in Claude 4 system card. And then your system cards, they actually drop this. They only mention RLHF and RLIF in 4.6 system cards, and for the newer system cards, they don't discuss it at all. But we have one more bit of evidence from their 2025 emergent misalignment from reward hacking paper, where they mention that they have a production triple H preference model, which grades the model responses to production queries, which means that at least like in November 2025, they had one single preference model that graded both honesty, harmlessness, and helpfulness of each response. So they probably still distilled the constitution into this preference model. Yeah, and in the Mythos system card, they mentioned that the character training and constitution became a large part of training for the first time. And they mentioned certain categories they train for in the character, be good for the user, be more creative, fun, funny, supporting user autonomy, all kinds of admirable behaviors, and they train the Claude to respect the intellectual depth and be more warm. So for the rest of the labs, we have even less data. Google says that they do data filtering and pre-training stage and reinforcement learning from human and critic feedback. They do some kind of pre-training monitoring, and they do SFT with adversarial prompts similar to constitutional AI in their own words, but there is no details about what exactly is going on there. But we can infer that they probably have some kind of preference model learned from human preferences and a critic that is a lambda judge that gives feedback on the responses, maybe close to generative reward models. And from Gemma 3, we know that they use Worm, which is weight average reward models, which is a tool to prevent reward hacking. So they train multiple reward models and average their weights, and it's harder to hack rewards from this merged reward model. From DeepSeek, we know that they have two reward models. One is helpful, one is safety. I think the most surprising thing to me is that they used very small data set. So they used just 66,000 pairs of preferences. They were not even human preferences. They were preferences collected by DeepSeek v3. And for safety, they use also just 100,000 prompts. So for helpfulness, they only trained on the final response. So no, reasoning wasn't affected by the training. But for harmlessness, they also showed the chain of thought to the reward model. And they use this reward model only for the final 400 steps of the training, which is probably like a very, very small part of the training pipeline, maybe like 1,000th of it. And if they tried to use it for longer, they got reward hacking. So back then, they didn't have the generative reward model. The generative reward model came later. Back then, they just used a Scala reward model. And Kimi is interesting. I know that this is like not the most popular model out there, but they have interesting details about the training pipeline. So they use the Kimi K2 itself to judge its own during the training. They first do SFT and preference dataset in generative reward model style to make Kimi better at critiques. And then they use it to judge its own outputs to generate preference signals. And they use rubrics predefined by humans. I will show them actually later. And they say that some rubrics are mandatory, but some are probably used only for certain kinds of questions. And the model can choose itself how much it weights one rubric versus the other. So their core rubrics are clarity and relevance. conversational fluency, and to be objective and grounded. And they have two more rubrics specifically to prevent reward hacking. One is no initial praise. I guess they learned from GPT-4o when it was very psychopathic. And the second one is no explicit justification. This is a very popular failure mode with LLMs that judge critics, where the model starts to just describe why this response is the best response possible, and the judge is just looking at it and agrees, yeah, this looks like a good response. So they had like a separate rubric to prevent that. And for Kimi K2.5, which is a newer version of Kimi, they used the generative reward models everywhere, even for the RLVR, for coding, for agentic tasks, everywhere. And it seems like they deepen their generative reward modeling pipeline. They do RL to also do the kind of things that DeepSeek described in their generative reward modeling paper. Yeah, I guess the rest is not that interesting. We know that for Quant, they used a lot of rule-based rewards, a bit of model-based rewards with the reference. So LLM as a judge compares two responses, and a bit without reference, but they were not clear what it means. For the rest of the labs, Meta uses DPO, which skips the reward modeling part completely and just makes the model more likely to output the preferred responses and less likely to output the dispreferred responses. So this works a little bit, but it cannot push the model too far from the initial model, so it doesn't become like very good at being helpful and very good at being harmless. Mistral also uses the same technique in the Ministral tree, but for their bigger model, Magistral, they don't even mention RLHF anywhere in the system card. They just say that they train from verifiable rewards. And for Grok, we can infer that they use a prompted judge to compare two responses. Oh no. My memes are not aligned today. So after reading all of the system cards, I am under impression that they are not reporting most of the stuff relevant to alignment at all. They do report some evaluations, but they mostly talk about verifiable rewards and performance in the coding and the math benchmarks and the coding and the math benchmarks and agentic benchmarks and terminal benchmarks and like all kinds of benchmarks, but nothing about alignment to human values. And you can still infer that labs use some kind of mixture of human verifiable, human preferences, verifiable rewards, and rules specs. The specs seem to gain weight, so they use more and more specs. The specs are enlarging in size over time, and the evaluations are moving from using the scalar reward model that outputs one number into prompted judges and generative reward models. And one more interesting lesson is that capabilities, helpfulness, and safety are learned separately on separate set of prompts. So there are like prompts that are relevant to safety, prompts that are relevant to helpfulness, and prompts that are relevant to math and coding. And the rewards are only given, like rewards for coding are given on prompts for coding, and the prompts for coding don't get any harmfulness rewards, for example. Yeah, that's it. Thank you all for listening. I guess you could have asked your questions for a while now, but we will wait a bit, and you can walk around, go to the bathroom, grab some water, and we will be back in a couple of minutes.
test. We'll probably just do 6 questions. 6? Yeah. Okay, 5. Do you guys mind here if you're here? You might be on stream. If you're if you're sitting here, sounds good. Yeah, for sure. Yeah. Oh, I have stuff there. Let me clear that out. We're gonna get started with the Q&A, so take a seat. In the interest of everyone's time, we're only going to be doing 5 questions, 5 or 6 questions. We're doing the most upvoted, so if you have any outstanding questions afterwards, please feel free to crowd around and don't let him leave until all of your questions are satisfied. So Ahan wants to know, how are constitutions made and how does AI understand constitutions?
So currently, constitution is mainly made by companies that train the language model, right? So Anthropic constitution is written by people at Anthropic. They have people who are hired to do this, like philosophers. They probably look at a lot of responses in their chat histories, like anonymized chats, to see where Claude answered well and where the Claude didn't answer well. They also publish those constitutions for public discussion, so people can read it and give their feedback, like, oh, I don't like this part. Can you please formulate this part more clearly? How much they actually follow those feedbacks is unclear, but they do update the constitution. So they published, I think, around 3 versions right now.
And also, if you're interested in more specific, I think Giles did a talk a few weeks ago on Claude's constitution. That should be on our YouTube channel, but that's specific to Claude. KP asks, human values are not universal, they differ. How can we align AI with like different contexts of human values and still ensure that it's being harmless, helpful, and honest?
Yeah, so there are multiple directions of work in this in this area. One is you can model the values as distributions, so you can have like multi-model values. So some people value this, some people value that. And you can make your preference models to also be multimodal. But I think the most prominent direction right now is to just make the model, like during part of its constitution is to cover both sides. So if there are multiple opinions about some question, the model should kind of give arguments for all of them, and as much as possible abstain to actually make a judgment in the end, just explain each point of view and then just say, basically, if you want to learn more, you can ask more, but I'm not here to decide what is right and what's not.
And then Giles asks, what do the self-generated principles look like? Are they human interpretable, and do they look like a human constitution, like in terms of like the form and things like that, or is it just like stuff we don't really understand?
Yeah, so they are human interpretable. You can read them. They are chain of thoughts, so they are kind of in human readable text. They are a lot shorter, at least from the examples they give in the papers. So it's just like one word and then one sentence describing what exactly it means to be that, and that's it. And the specs are tend to be a lot more in depth about how exactly you should behave in this situation. What does it mean to be that? What does it mean to this?
And then Alicia asks, how would you encode values that are emotional or subjective? So she gives the examples connection or freedom into AI.
yeah, I guess we all want to know how to do it in the best way possible, right? But you can, in principle, write what it means to be free. So that's one approach, right? You make freedom part of your constitution and you explain what it means for a person to be free, what it means to limit the freedom of a person, and that AI should not give answers that will promote limiting somebody's freedoms. But yeah, overall, it's a hard question, and maybe those are just latent in our preferences. So maybe even just when you train these classifier models from human preferences, and humans prefer answers that promote freedom and not promote some kind of slavery, for example, that might be enough.
And then we're just going to do one last question, and then again, if you were one of the most of the questions that didn't get answered, you can ask them yourself. How do we interpret the harmfulness and helpfulness ELOs in the CAI paper? What does it mean to have an ELO of 50 versus 100?
Yeah, so ELO is a way to compare two models, right? So I believe it was invented for chess, and in chess the interpretation is how likely one player will win over the other player. And for the constitutional AI paper, they set ELO of the base model to be 0, and ELO of 50 means that a model has like a certain probability to produce more harmless or more helpful response compared to the base model. Yeah, and like 100 will mean that this probability is higher. I'm not sure about the exact formula though. Yes, negatives can happen if the model is less likely to produce a harmless response, for example.
Let's get another round of applause for today's talk. So we will be around for at least about another hour. So yeah, please finish up the food and talk.